are going to move from angles. Well, we'd already started talking about, not yesterday, but the day before, about some segments, right? Like we learned how to calculate a chord if there's a radius that goes through it, right? Because what do we know about that radius? Julia? It's perpendicular and a bisector. Right, it's perpendicular and it's a bisector of the chord. So we learned that. We learned the ice cream cone theorem, which says that this, if you draw two tangents from the same point, they're equal, right? And we reviewed that if you draw a radius to the point of tangency, those they make right angles, right? So we learned all of that. Now we are going to learn how to measure these angles that Cameron was wishing, or these sides that Cameron was wishing he could do yesterday, like the lengths of the chords inside there, or the lengths of these secants here. Okay? Yeah. Well, not to solve for angles, but you would need them. Like, what if I said, what's the distance from H to F? Not what angle does it make, but what's the distance? Okay? All right. So, that's circles. And then all we have left is circles after that, and then we're done. We're going to figure out the equation of a circle, and then we're going to be done. All right. So, but today we're just working out the lengths of segments inside the circle and outside the circle. Okay? The first theorem is the chord-chord product theorem. So that's going to talk about two segments that are inside the circle, right? Because the chord isn't allowed to go out. So the chord would be CE and AD, right? Okay, the chord-chord theorem says that if you've got two chords that intersect inside the circle, okay, then the products of the segments that are created by their intersection are equal. So in exact terms, that means what that says is AB times BD is equal to CB times BE. Okay? So when you have two chords that intersect inside the circle, the product of these two pieces equals the product of those two pieces. Okay? Or if it's easier to name them, like if the letters are freaking you out, 1 times 2 equals 3 times 4. Okay? Or if I even put lengths in there, let's say if this is length 4 and that's length 6, this would be length 2 and that would be length 12. Because 4 times 6 is 24, 2 times 12 is 24. Okay? So obviously what we're going to do is one of these is going to be missing and you're going to solve for it. Okay? All right. And this actually I think is very interesting. In archaeology, and this is actually a case, but I mean, they do this all the time. They found a piece of a shield, and they wanted to know exactly how big the shield was. Because you think about it, like how big, archaeologists who can't see the people they are studying, they can use things like how big the shield is could determine how big the person that was carrying it was, right? It wouldn't, like a really big person wouldn't carry a little tiny shield. It's ridiculous. Or vice versa, a really little person couldn't carry a really big shield. So it's like gives them all kinds of information. All right. So what they did was they drew, like they had this piece of a shield, but they didn't know exactly how big it was. So they drew a circle around it, okay? And they said, okay, this is the widest point, okay? And they drew, so then they drew a diameter, okay? And and then they drew a perpendicular bisector. And they want to know what the diameter of the chord is. Okay? Yeah.
How do they know how big the diameter, like, how big to draw the diameter, like how wide the side is?
Yeah, they don't. They're trying to find the original diameter. Like, yeah, you're right. They don't know that this broke exactly in half. So they don't know that's the diameter. They're trying to find the diameter. So this is the one that they're trying to find. Okay? And this is just from edge to edge on the shield, but it could be diameter, could, we don't know. So that's what we're trying to find. So what they did was they drew, and we know that if you draw a radius or diameter through a chord, and it's perpendicular, that's perpendicular bisector, right? So if from here to here is 5, how much is it from here to here? 5. Okay? And let's see, I should have more. Okay? And then they measured this. Okay? Because they know from the top to there, that's 3, because they could measure that. Okay? So now all they have to do is find that piece, and that will give them the actual diameter. Does that make sense, everybody? Okay? So using the chord theorem we just learned, 5 times 5 should equal 3 times x. So I get 25 is equal to 3x, and x is 8 1/3. Right? So what's the diameter of the shield? 11 1/3 inches, right? It's a very small shield. Yes. I know.
A little tiny board.
I'm wondering if it's just like a hand plate or something, because that's. All right, but that is the chord theorem. Okay. Then we have this secant. But first, let's do a little bit more vocabulary. I know, sorry about that. All right, the external secant segment is the segment that lies on the outside of the circle and has one endpoint on the circle. So like the secant segment would be from here to here and from there to there. Okay? That's the external secant segment. The secant segment itself has at least one endpoint on the circle, like this. Okay, this one has 2. All right. So we'll just be using those in these theorems. So I just want to make sure everyone knows that. Okay, so the secant product theorem says if 2 secants intersect on the outside of the circle, then the product of the lengths of one secant segment, so that's here, and its external segment equals the product of the other secant segment and its external segment. Okay? So, so in letters, they're saying, now this is a hard part for people to remember. In chord, you just took the 2 pieces, right? This piece, this piece, this piece, this piece. But in secants, you use the whole thing times just the outside is equal to this whole secant times just the outside. Okay, so you just have to remember that. It's just it's just something you have to memorize. So so we're saying AE times BE has to be equal to CE times DE. Does that make sense? Okay, so if this is 5 and this is, I think of something that would be, do 5 minutes. Okay, so let's say that's 2. How would I set that up to find CD? AB is 9. Sorry. So if AB is 9, BE is 5, and DE is 2. Well, first of all, what would go on the left-hand side with the AE stuff? Right, it would be 14, which is the length of the whole thing, times 5. Okay, now, whoa. So that's,
That was really weird.
there's a sun over there. Maybe she's going to work against the wall. If that's x, what's the length of the whole thing? X plus 2, right. Times 2, right? The whole thing times the outside, whole thing. Thank you. Times the outside. Okay? So that 14 times 5 is 70. And then I get 2x plus 4 by distributing the 2. Okay? I subtract the 4, and that gives me 66 equals 2x. So x must be 33. Yep.
So you're not doing just the eight, the longer part times the smaller part equals the.
It's the whole thing times just the outer, and this whole thing times just the outer.
So it'll always be set up like that.
Yep.
Wait, Miss Archer. How did you get? Oh, never mind. I got it. Sorry.
Because wouldn't
You want to do a couple examples?
yeah? Because I feel like I know what you're saying. It's just that what that and what you did just seem really different to me. I don't know why.
Okay. Well, let's do some examples like they thought. All right. Oh, and the last one. What if I have a secant and a tangent? So I don't have two pieces. Right. Exactly. You take, it's the same thing, so it's AC times CB. So the secant always gets treated the same. But since there's no inside piece here, I just take CD and square it. Okay, so everybody got those? Let's work these two. Right? Find y and x. And those do intersect. I didn't draw them very well. All right, let's do this one first. What would the equation be? Right? Right. 3 times 4 equals 2 times y. So 12 equals 2y, and what's y equal? 6. Good. Okay? Now for that's 2 chords. How about 2 secants? What would the equation for that be? X plus 5 times 5, so the outside times the whole thing, is equal to 12 times 6. The whole thing, which is 12, times just the outside, which is 6. So 12 times 6. Right. Exactly. Exactly. So I get 5x plus 25 equals 72. Subtract 25, I get 5x is equal to what, 47? And divide by 5, and I get x is equal to 9 2/5.